I welcome all of you to the day 9 of our online faculty development program on artificial intelligence, machine learning, and data science for engineering application. So today we have two sessions. In the first session, we'll discuss about a recommendation system. Second session, we will go for natural language processing by Professor J.K. Raut from NIT Raipur. So, recommendation system is a very popular platform for today's business or today's, I can say, industry. So, it is a specific application of data science and machine learning, where you need supervised, unsupervised, reinforcement, transfer learning, and other mechanism, as well as you need the insights about the data science. So it is a multidisciplinary field, we can say, where you need the knowledge of probability statistics, data science, machine learning, and other related technology. So we are going to discuss. I'll cover the whole recommendation system into two different sessions. One in today's lecture, another is in tomorrow's lecture. So today we'll see some of the basic things related to recommendation system and its types. And tomorrow I'll tell you about some of the advanced part of recommendation system. So these are the topics that we are going to discuss. First, I'll introduce the recommendation system, and we'll see what is the basic architecture of the recommendation system in abstract level. Then I'll tell you about the types of recommendation system. Initially, I'll divide the recommendation system into two parts. One is collaborative filtering approach, another is called as content-based approach. And further, these two types are again divided into another two types. So they are called as memory-based approach, another is called as model-based approach. So overall, if you see, there are four different types you will get. In collaborative filtering, you can get memory-based and model-based. Content-based case also, you can get memory-based and model-based. So we'll see all these four parts, but initially we'll discuss about the collaborative filtering system and content-based system. Then I'll tell you about the three specific questions that we are going to address in the recommendation system based upon the abstract architecture, I can say, in a very broad view of architecture. So that three questions we are going to discuss with respect to various angles, right? So for example, if somebody can ask, if I design a recommendation system, now how I am going to evaluate the accuracy of my system, right? So not only accuracy, other factors are also there. We have precision, we have F1 score, recall, we have mean absolute error, root mean square error, various type of measures we have to evaluate the performance of the recommendation system. So that I'll tell you, and we'll conduct two activity 1 and activity 2. Activity 1 is again divided into two phases. One is designing the recommendation system, and another is evaluating the recommendation system. Similarly, in activity 2, I'll take a very popular machine learning model, I can say, that is called as K nearest neighbor algorithm. So with respect to KNN, I'll tell you what are the problems, and also with respect to KNN, I'll tell you two important problems which will do a hands-on activity. Then I'll tell you about various type of similarity function, like if I consider two different users. Okay, then what is the similarity between these two users? If I consider two different, so what is the similarity between two different items? So based upon that, you can make a assessment, right? So if you look into that, we have different similarity measures, like we have mean square difference, we have cosine similarity, we have Pearson correlation. Similarly, if you go for aggregate function, when you are getting the ratings from different users. So if you want to aggregate multiple sources, suppose you are collecting the data, and if you want to aggregate it, so for that also a different type of technique is, you can go for average, you can go for weighted average, you can go for difference from mean and other methods. So some of those methods we are going to discuss under similarity function, followed by the conclusion and references. So this is the agenda for two lectures, today's lecture and tomorrow's lecture. See how much we'll cover today, and after that, wherever we stop, next session I am going to continue from that up to the conclusion. Now, coming to what is a recommender system. So you can see there is two basket here. One is called as recommender, another is called as recommendation in one basket. In another basket, you have system, platform, and engine. Okay, so we can say recommender system, or you can say recommendation system, or we can say recommender platform, or recommendation platform, or recommender engine, or recommendation engine. So all are synonyms, right? They are used alternatively. So recommendation system is same as the recommender system, or whatever you can choose from these two baskets, one after another. So they are same. Okay. So the first definition, if you look for recommendation system, it is a subclass of information filtering system. So what is the meaning of subclass? Subclass means like if you consider a classroom teaching. So suppose in your classroom, you have 90 students. So I can say a particular class is having 90 students. But when I say subclass, let's say I'm taking 30 students out of 90 students. So that is a subclass of system. Now it is saying a subclass of information filtering system, because all the information that we gather to make recommendation, that is not important. Okay, there are many measures are there. So all of these measures are not equally important. So we need some kind of filtering. For example, suppose you want to make a call. In your contact list, you may have more than 1000 numbers. So, but you want to call to one of the contact, right? So what do? You filter, right? Filter by name, filter by number, filter by other different type of filtering mechanism. So here we are doing information filtering system. Okay, so based upon the information that are available to us, we filter some information, and those informations that are useful to my model. So I am considering that those informations are not important. I am not considering it. Okay. So rather than considering the whole class, we are considering the subclass of a particular system, right? Because class is very large. So analyzing the entire class is very difficult. Moreover, whenever you are analyzing a particular class, at that time also other things are also generated, right? So we are not considering it a real-time basis, right? So we are considering a subclass of the system. So that is one part of our recommendation system. Another part you can say, predict the rating or preference a user would give to an item. Okay. So you have to predict. For example, I'm going to purchase a particular product, let's say air conditioner. So what rating I am going to give after purchasing that item? Okay. So I may rate 4 out of 5 if it is a 5-point scale, or I can rate 3 out of 5, or I can go 2 out of 5. So based upon my assessment, I will do my rating. So recommendation system also helps us to predict the rating and preference a user would give to an item. Suppose you have purchased, let's say, X item, you also purchased Y item. So recommendation system will help you to suggest another item to you. Right? In this way, we can say the recommendation system can be defined. So there are many applications of recommendation system. For example, if you talk about Netflix. So in Netflix, we are using for watching movie. Suppose you like, let's say, romantic movie, right? So if you have watched 2, 3 romantic movies in Netflix, and if a new movie released in the market, which is of romantic type, then that particular movie is going to be suggested by Netflix to you, right? Because you have some interest in that type of movie. As somebody also interested in, let's say, crime type movie. Then, if a new movie released with the theme is crime, so that if that is available in Netflix, Netflix is going to suggest that particular movie. So how actually Netflix provide you that thing? Netflix is providing you that because of the recommendation system. Or if you talk about YouTube, all of us are using YouTube. So in YouTube, suppose you play a particular video, and what once the video is means over, right? It is completed. What is the next video that YouTube is going to suggest you? So for that also you need recommendation system. Similarly, if you talk about Spotify, so nowadays it is very popular to watch, to listen the music. So there also recommendation system works. Suppose you listen a particular music for, let's say, 10 times. So whenever you select that songs randomly, then definitely that song is going to come because you listen that particular music for 10 times. Similarly, if you talk about e-commerce site, so all of us are doing shopping in Amazon or Flipkart, eBay, Levi's, and other sites. So there also recommendation system works. For example, when you purchase a air conditioner, so your Netflix or sorry, Amazon or Flipkart e-commerce sites, they suggest that in addition to this air conditioner, if you purchase a, let's say, stabilizer, then you will get, let's say, 10% extra discount. Okay, or you will get 100 rupees cashback. There also recommendation system works. Or if you talk about social networking sites, like Facebook is a social networking site, Twitter is another social networking site. There also we are using recommendation system. Like suppose you have my mobile number, you have saved my mobile number in your mobile. Okay, you have saved my mobile number in your mobile. So your mobile is having Facebook, and my mobile number is also attached with my Facebook account. So in people you may know, in that you my name is going to appear if I am not a friend in your Facebook profile. So that is also done by the help of recommendation system. Okay, or Twitter is also an example of the recommendation system. Now, coming to based upon this definition, if you want to see the broad view of the architecture of the recommendation system, the broad view is divided into 4 parts. So one is database, another is user, another is recommendation system engine or platform or process, I can say, another is set of items. Okay, so you can see there is 4 components in this picture, right? User, database, recommendation system, set of items. So what is a database? Database is used to store the details of different users and their interest or their items. That is called as our database. Okay, which user purchased which item, or X user purchased how many items, what are the type of item X user is interested, right? So that is kept in the database. Okay, so you can use any database, or if you cannot visualize a database, then you can take Microsoft Excel file where you have set of rows and columns, right? Set of rows and columns that can be also considered as a database. Okay, so where you can say the rows indicates the user and columns indicates the items. Okay, so suppose a user has purchased an item, then in the corresponding row and corresponding column, some value is written. So that value maybe I can consider as the feedback received from the user. right? So that can be considered as a database. Similarly, there is a recommender system. What recommendation system will do? Recommendation system needs the history of the different user. For example, I want to suggest some item to a particular user. So I should know what are the items purchased by that particular user, or what type of items the user is interested. So based upon that only I can suggest a particular item, right or not? So in that case, recommender system will work. So if you design an intelligent system, so those items will be suggested by that particular recommendation system. User is going to receive it. Right. Suppose, let's say in this case, two movies are recommended by the recommendation system. So if user is really interested in these two movies, user is definitely going to watch that particular movie. Right or not? So recommendation system, whatever you want to going to build, so that should be an intelligent system. And in order to build an intelligent system, you need the help of artificial intelligence, you can say, machine learning, you can say, deep learning, you can say, generative AI, you can say, transfer learning, you can say. The different mechanisms are there. Or I can say AI techniques are there in general. So you need generic systems and also you need the specific systems. Generic means overall view. Specific means a particular user. A user level, I can say it is a specific. But overall recommendation system, if when I consider a set of user, then I can say that is a generic way we are representing the system, right? So designing a recommendation system is the really challenging. And that recommendation system you are designing to suggest some item to the user. That is called as a set of items, right? And we have to check that whatever items our recommendation system is suggesting, whether user like that particular item or not. So that's why whole recommendation system is divided into 4 parts: user, anyhow it is a specific user, database, recommender system, set of items. Okay, these 4 comprises of the architecture of a recommendation system in a broad level. But I will also tell you a detailed diagram so that you can easily understand what are the internal components of a recommendation system. Now, in which domain you can apply? Like if you look into the previous slide, as I mentioned, I am suggesting 2 movies. So I need a movie recommender system. Somebody can also use recommendation system to suggest appropriate news to different users. For example, suppose you are interested in political news. You don't interested in any entertainment news. So your recommendation system is going to suggest the items that are related to your interest. That is political news only. So that is there also you need a recommendation system. Somebody is interested in music domain. Okay. Somebody is interested in the music domain. Music domain means, for example, you are listening one type of music and you want to suggest new music to a particular user. Their music domain will also work. So recommendation system is not limited to a particular domain. It can be utilized in different domains. For example, if you go for movie domain, Netflix is used for movie. That is one of the example. Film affinity is also another example of movie domain. Or movie lens is another example of movie domain. So if you want to really do work in this particular area, there is a open source data set of movie lens are available. And this the database size also varies. Right? If you see the data set size is varies. For example, you can get movie lens data set in GB. You can get movie lens data set in MB also. Okay, suppose your system is capable to process gigabytes of data, then you can take GB data set. But if you want a smaller version of the data set, that is also available or movie lens. So that you can use in the simulation purpose to check the performance of a particular recommendation system. Okay. Now, with respect to these three components, although I told you 4 components, except user, we have 3 components. Okay, so if you talk about these 3 components, database, recommendation system, and set of items, so there are 3 fundamental questions. What are the questions we have? First question says that which information do we use to make recommendation? Okay, which information do we use to make recommendation? That's why I told you all the informations are not important. Okay, whatever information is available, all are not equally important. Right. So you have to find the information that are useful to make recommendation. Okay. The second question says that how to implement a recommendation system or how to design a recommendation system. Once you design, you can think about implementation, which programming language you are going to use to make recommendation. For example, you can use Python, somebody can use R, and somebody can use the traditional programming languages for making the recommendation. Okay, designing the recommendation system. But at the same time, you can, if you are not having expertise in any traditional programming language or Python or R, you can also implement the recommendation system using Microsoft Excel. If you write the ratings in the form of rows and columns, okay, so you can implement the recommendation system using Microsoft Excel. Okay. So I'll show you while we will conduct the activity. Okay, I told you I'll show you 2 activity. So in one of the activity, I'll show you how to implement the recommendation system using Microsoft Excel, so that you have an idea. So even if you don't have any expertise in any programming language, if you know about Microsoft Excel also, you can do it. And the last question arises, if you develop a recommendation system, how to evaluate a recommendation system? So anything you can evaluate using some matrices. Okay, anything we can implement using some matrices like student performance you are assessing through CGPA or SGPA, or I can say you can evaluate the performance of extracurricular activity with different measures. Similarly, here also in order to implement evaluate the recommendation system, we use some matrices like precision, recall, F1 score, accuracy, mean absolute error, root mean square error, and so on. So that will help you to evaluate the performance of a recommendation system. So what I'll do now, I'll address these 3 questions through some examples. Okay, so that you can easily understand what is the meaning of these questions and what I'm trying to address using these particular questions. Let us concentrate on the first question. Like, which information do we use to make recommendation? So here, if you look, then in the database, if you look into the database, suppose in my database, I have, let's say 4 users, or I have taken 4 users from my database. So let me call this user as user 1, user 2, user 3, and user 4. Okay. Similarly, for item, okay, these are the users. For item, let me call this is item 1, item 2, item 3, item 4, item 5. So I represent everything in the form of an item without specifying movie, music, or I can say item, product. So we generalized, we use these terms alternatively. So in general, we represent it by item. So item does not mean only product. It may be a movie, it may be a music. For example, if you look into this particular item, which is a movie, if you want to find its properties, then you can see this movie is characterized by these properties. One is genre. Genre means its type. What kind of movie? So it may be a drama type movie, it may be a romantic type, it may be a horror type movie. So for this, it is a drama type movie. And each and every movie is directed by someone. And the running time of the movie is 175 minutes. And a little bit information about the movie that is called as plot. Similarly, if you talk about this particular movie, this movie is of romantic type. Okay, so this movie is the Titanic movie, if you ever have, and it is directed by James Cameron. Running time is 195 minutes, and a abstract about that particular movie, which we call plot. So every movie having some property that is called a genre, directed by, running time, and plot. So these properties are also helpful for us to suggest some item. For example, somebody is interested in drama type movie, or if somebody likes James Cameron is the director, then definitely the movies are good. Or somebody can say that if the running time is below 2 hours or more than 2 hours, then only I am going to watch this particular movie. So like that, you can characterize different type of items. Okay. So basically, we call this is a content-based information. Okay, based on a particular content, we have some information. Now, coming to feedback. The feedback is of two types. One is called as explicit feedback, another is called as implicit feedback. So what is explicit implicit feedback? So if you see the difference, explicit feedback, in case of explicit feedback, a system where we rely on the user giving us explicit signal about their preference. Suppose you purchased a particular item as a user, you purchased a particular item. Okay, let's say item I1, user 1 has purchased an item I1, and let's say user 1 received that particular item and rated the item 4 by 5. So this 4 by 5 is an explicit signal, right? Rating is an explicit signal to evaluate a particular product or an item. So if you do so, that is called as explicit feedback. Or this person has gone through a web page or a troubleshoot page. After reading the troubleshoot information, it is asking whether this information is useful or not. And this user saying, yes, it is useful. Yes, it is useful. So that is also providing an explicit signal. That is also providing an explicit signal. So that is called as your explicit feedback. So something you are expressing, that is called as explicit. But sometimes user is not providing explicit information. For example, you ordered something from Swiggy and Zomato. Once the order is delivered, if the order is okay, then you don't want to rate the particular item. Only the product is not good, then you are writing the product is not good. So there you are not providing explicit signal. If the item is, you don't like that particular item, then only you are giving explicit signal. But if the item is good, you are not providing explicit signal. Okay. So now if you come to implicit feedback, here user clicks and queries and watches to infer the preference. For example, if you are watching a particular, if you are watching a visiting a particular website and there is an interesting ad coming in the left or right panel, and you are interested in that particular offer or that particular ad. So what will happen in that case? Okay, definitely In that case, what you will do? Definitely, you will go. Definitely, you are going to see that particular ad. Okay, seeing that particular ad. So in that case, your intention is not to visit that particular ad or that offer. Your intention to visit a particular website. Okay, but as the offer or ad is more attractive, you are visiting to that particular site. So there is a click, or you posted a particular query in some public platform and somebody is addressing to your queries. Okay, so in that case, you are not showing any explicit signal. Okay, you are not providing any explicit signal. Rather than you are providing some implicit signal through which we can extract the feedback. But getting that feedback is really challenging. Like lack of clicks is implicit lack of reference. If somebody is not visiting the other websites whenever they are visiting or browsing the various pages, they are not looking into different ads. They don't click to different offers. So in that case, there is a lack of clicks. So lack of clicks leads to lack of preferences. Okay. So now this is the basic difference between the explicit feedback and implicit feedback. For example, if you see here, I asked this particular user to rate the item 2, and the user has rated 2 out of 5. So it is an explicit signal. If you are rating something 2 out of 5, then you are providing an explicit signal. But when I ask this particular user to say about item I4, the user is only mentioning that the user has seen that particular movie, but there is no explicit signal. Okay, whether the movie is good or bad, just this is just like a view kind of thing. You are looking into that particular ad, but or movie, but you are not expressing anything. Okay, so that is also one type of feedback, but inferring from that particular feedback is really challenging compared to explicit feedback. Similarly, we can go for demographic information. In the demographic information, we look into gender, age, and profession. For example, if you look into recommendation system, like many e-commerce sites also, uh, they categorize the product based upon the gender. Okay, so there is some products they belongs to male category, some product belongs to female category. So based upon that, they segregate the information. And some sites they also categorize different products based upon the age. So different age groups you can take, like 0 to 10, 11 to 20, 21 to 30, 31 to 40, or 41 to 50, and so on. So based upon that also you can make categorization. Or another is called is based on the profession. For example, there are some corner or we can say some tapes which may be specialized to a particular profession. So on that basis also you can make different categorization. So we call that as a demographic information. So if you look into this user, the user's gender is male, age is 18, profession is student. Okay. Like if you look into this particular user number 3, gender is female, age is 27, and profession is journalist. So these are the properties of a different user. These are the properties of different item, and these are the properties of different users. So these properties will help you uh, to go for recommendation, right? Similarly, we have social information. Like you can see these two users they are connected to each other. So they are friends. Okay. And somebody can say that friendship can be categorized into a particular range, let's say 0 to 1, where 1 indicate that they are close, they are having close friendship, and 0 is having, let's say, they don't have any friendship, no friendship to close friendship. So that categorization also you can make. Or trust can be also part of a social information. Reputation can also be a part of social information. So based upon that also, you can make recommendation. For example, user 2 and user 4, they are very close friends. Okay. User 2, user 4 are very close friends. So if user 2 purchase a particular item, then U4, if U4 comes to know that U2 also purchase this particular item, then U4 is going to purchase that item. Okay, so there also recommendation system can help you. Okay, but the problem in this case, you have a lot of information. You have content-based information, you have feedback-related information, you have demographic information, you have social information. But which information you are going to, use for your recommendation, that you have to think. Not all informations are important for building the recommendation system. Now, this I already told you, what is the difference between explicit feedback and implicit feedback. Now, if you come for database perspective, if you look into the database perspective, so let us understand how these informations look like. Okay. For example, if you go for content-based information, so for each movie, okay, for each movie, you are calculating, you are maintaining the informations like genre, directed by, running time, plot. So I can make a table. In my table, okay, in my table, what I'll mention, for each and every movie, I'll mention an item ID. And each and every movie is a type that I'll mention, or a genre. Each and every movie is directed by someone, and what is the running time of the movie and plot of the movie. So there I'll keep the information related to all the movies. So that is one type of table. Similarly, if you go for feedback, okay, there is a explicit feedback and there is a implicit feedback. So for example, I want to keep rating. So I'm making a table where I mention user ID, item ID, and rating. For example, I can mention user ID 1, item ID I1, let's say rating is 4. User ID 1, let's say purchased item, let's say number 5, rated 5 out of 5. Okay. Similarly, sometimes if you don't want to represent in the form of ratings, so we can go for how many times you have watched a particular movie or a music, listen to a particular music. That also we can do. So I can take user ID, item ID, and number of items. Okay, for example, I can say user 1 listened item number 6, which is a music, for 30 times. So that can be maintained in this particular table. If you come to demographic information, so every user is having a age, I can say gender, or we can say professions. Okay, so that also we can maintain. User 1, what is the age, what is the gender, and what is the profession. User 2, what is the age, gender, and profession. Similarly, we can keep social information. In social information, we can mention user ID 1, let's say user ID 2. Okay, let's say they are very close friends, so I am giving 0.99. And U1, let's say, has never met user ID, let's say 9. So I am putting trust is 0.00, something like that. So in database perspective, we put them in the form of table so that we can easily represent them. And there is a dependency again in between tables. Like sometimes I need item information, I need user information. Sometimes I need a rating matrix along with item information. Sometimes I need rating matrix with the user information. So like that, I can suggest whenever I'm designing the recommendation system, some of these informations are useful. Now coming to different types of recommendation system. So here you can see there are two different type of recommendation system. One is collaborative filtering based recommendation system. Another is content based recommendation system. So in collaborative filtering system, we build a model from a user's past behavior. Suppose a user has purchased 10 different items from a e-commerce site. So based upon the user's past history, okay, user's past history, I am going to suggest a new item. Or based upon user's past history, I created a model. Okay, I have given the input to that particular model, and the model has suggested a particular item to for that particular user. Okay, that is called as collaborative filtering approach. But when you go for content-based recommendation system, there content-based approaches utilizes a series of discrete characteristics of an item in order to recommend additional item with similar property. So you have to look into different characteristics of an item. For example, if you look into different characteristics of a particular item, we have item in every movie case, we have genre, you have a director of a particular movie or plot of a particular movie. So based upon that, you will get certain characteristics, right? So once you understand the existing characteristics, we can suggest some additional items that are satisfying the same properties. Okay, based upon that, we are going to suggest the different items to the user. So let us see these two types of recommendation system using one example. For example, here you can see, let's say user 1 and user 2. User 1 has purchased one item, let's say I1. User 2 has purchased another item, let's say I2. Okay, let's say it is a book. Both are books. So we can say I1 and I2, if you see the content of these two books, they are more or less same. U1 purchased I1, U2 purchased I2. The content of I1 and I2 both are same. Okay. Same means I can say, let's say recommendation system book by X author, recommendation system book by Y author. The later point of time, let's say user U2 purchased another book, that is I3. So as their past experience, based on the past experience, you can conclude that they have similar interest. So whenever user U2 purchase a particular item I3, that particular item I3 is also suggested to user U1. Why it is suggested? It is suggested because these two users are having similar interest. That's why I told you in collaborative filtering system, we build a model based on users' past behavior. Okay, but when you go for content-based filtering system, instead of taking similarity between two different users, we find similarity between two different items. For example, user 1 purchased a book, let's say I1, and in later point of time, let's say I2 is released in the market. And we have seen that item 1 and item 2, they are similar to each other. Their content is similar. Like I mentioned, the same content is covered by two different users. Then item 2 is going to be suggested to user U1. So how I2 is suggested to U1? Based upon similarity between I1 and I2. That's why we look into different characteristics of item to suggest some additional item like this. which is having similar properties. That is called as content-based recommendation system. Okay. So if you see in the database perspective to understand what is the difference, so you can see here in collaborative filtering system, you are given with the rating matrix. So rating matrix means you are given with user ID in rows, item IDs in columns, and with respect to a user and with respect to a particular item, what is the rating? Okay. So the element, just like if you can say Excel sheet, in row we have user, column we have items, and every element represents a particular value. Or on the other hand, I can say you are given with the user ID, item ID, and how many times, number of times. Okay, number of times, like 30, 40 times. Suppose I watched a particular music, so the value will be written there. So let us see one example to understand. So in collaborative filtering system, these metrics are given to you. Either a rating matrix is given to you or a consumption matrix is given to. Okay, now if you look into this particular example, the idea is more clear. Like here you can see, I am showing you a sample sheet where we have 11 different users and we have 15 different items. 11 different users and 15 different items. And every user has not purchased all the items. It is not possible for a particular user to purchase all the items. So, like if you talk about user U1, U1 purchased I1, I2, I3, I4, I5, and I7. However, user 1 has not purchased I6 and I8 to I15. But when you see user U2, U2 has purchased I1, I2, I3, I4, I5, and I7. Like user U1, U2 also purchased the same item and other items are not purchased by that particular user. Now, if you see this example, what this blank space indicate? So this blank one indicates the corresponding user is 2, corresponding item is 10. So I can say user 2 has not rated the item I10. User 2 has not rated the item I10. Right? But what this 4 indicates? This 4 belongs to user number 6, item number 7. So I can say user 6 has rated item 7 4 out of 5. So if the value is written, the value is in between 1 to 5, where 1 indicates, let's say the product is poor, 5 indicate, let's say the product is excellent. Okay. And you can see most of the values are not filled because all users are not purchasing all items, right? So you have not purchased all the items from an e-commerce site. So those items you have purchased, for that item, you have the ratings. However, sometimes the metrics look like this one. What it indicates? It indicates that either the value is +1 or the value is -1. So what +1 indicates? +1 means this +1 belongs to user 6 and item 6, which indicate that user 6 like the item I6. Right? +1 means user 6 has an interest in that particular item. But what this -1 indicates? -1 belongs to user U2 and item I7. So that means we can say user 2 dislike the item I7. Okay. And obviously the blank indicate that the user has not rated that particular item. So in this way, we can say that whether a user like an item or unlike item. Like I mentioned, after reading a troubleshoot page or a blog, the last it is asking whether this information is useful. And there is a thumbs up button and there is a thumbs down button. So if you press thumbs up in the database, we'll add +1. If you put thumbs down button, then we'll put -1. So in this way also we can represent a particular matrix. Now, if you see this particular matrix here, like previous one is either +1 or -1 or blank, or you can say 0. And previous to previous one, we have the values from 0 to 5. Okay, 0 to 5. 1 to 5 indicates that you have given the rating, 0 indicates that the user has not rated that item. But here, there is no specific range. The value starts from 0, but upper limit is not known to us. For example, what this 15 indicates? This 15 indicates that user 1 listened the music I1. If it is about the, let's say, music, then I can say user 1 listened the music I1 15 times. Okay, similarly, user 1 listened the music I3 how many times? 55 times, and so on. Okay, and so on. Right. So here we don't have any upper limit. So suppose that user is again listening, so 55 will change to 56. Again listening, then 57, and so on. So that is also one type of representation in the database. Now, if you go for content-based system, in content-based system, the rating matrix is not given to you. Like you have earlier a user item rating matrix or a user item consumption matrix, but that matrix is now not given to you. So what is given to you? You are given with the item properties. You are given with the user properties. What are the item properties? The item properties is, for example, a movie domain. Who is the director? What is the type of the movie? Okay. And let's say what is the running length of the movie? Who are the actors, actress in that particular movie, and so on. Based upon that, also you can make recommendation. So this is nothing but the item properties. Similarly, you are also given with the user properties. For example, for you, every user, I am collecting what are the type of movies the user like. Okay, so that also you can mention. So content-based system, the item feature and the user feature is given to you, whereas collaborative filtering system, you are given with the user item rating matrix, and you are given with user properties or item properties. So if out of these three, user properties, item properties, and rating matrix, if any two is given to you, then you will be able to find the third one. So which will help you to make the recommendation. So let us take a small example to understand how actually this collaborative filtering system and content-based system actually works. So let us consider a e-commerce website and assume that this site sells thousands of smartphones. But for the easy illustration purpose, we consider only 5 smartphones. And each and every smartphone has two features, that is the assumption. And the two major feature is, one is battery, another is display. One is battery, another is display. Okay. So for example, if you look into this particular matrix where I am showing you 5 different smartphone and their battery value and display value, so that we call it the item feature matrix, because smartphones are considered as an item and it is given with the features battery and display. So we call this matrix a item feature matrix, which is having discrete characteristics of the item. So as we consider 5 different smartphones, so you have some value for battery, you have some value for display. And for easy illustration, sum of the feature value. Okay, for example, if you talk about smartphone 3, battery is 0.99, display is 0.01. So sum of battery value and display value is equal to 1. Now, if you go for another matrix, that is called as user feature matrix. So in user feature matrix, like items are mentioned. In the user case, usernames are mentioned. For example, I am taking Aman, Bob, Chandan, and David. These are the 4 different users. And based upon their like and dislike, there is a value for battery and there is a value for display. In sum of the value of battery and display is equal to 1. For example, you can see Aman mentioned that he prefers battery over display. It's an ideal smartphone feature. For example, if you talk about battery, so Aman has given 0.9, okay, out of 1 for battery and 0.1 for display. However, if you talk about Bob likes a long-lasting battery. So battery is given as 0.80 and display is given 0.20. Come to Chandan, display should be decent and battery should be normal. As display is given more importance, display feature value is 0.9, whereas battery value is 0.1. Now coming to David, display is extremely important, but not the battery. So again, display is 0.99 and battery is 0.01 because display is more important. Like either for a user, you are given with a natural language text, which you have to use to convert the natural language text into a display value, or you can directly ask the user to write the values, features value in such a manner that the sum of the feature is equal to 1. Now, if you go for collaborative filtering based recommendation system, okay, in case of collaborative filtering system, you have 4 users and 5 smartphones. So you are given with the user item rating matrix. So as user item rating matrix is given to you. So it is a 2-dimensional matrix, just like a Microsoft Excel file. Row indicates user, column indicates the item. And the values, if a user has purchased a particular item, then the value is in between 1 to 5. And if a user is not purchased an item, that is put as blank or 0. So we do not know the features of the items here, assume that, but you have given with the user behavior. That means item feature matrix is not there, but user feature matrix is there. That is how the users rated the existing items. So if a item feature matrix is not given to us, we can assume in terms of variable. So we consider the feature vector for a particular smartphone, let it be S1. We assume that it is equal to X1 and X2. So S1 is defined with 2 features. One is X1, another is X2. Obviously, X1 represents, let's say, battery, X2 will represent the display. But we know when you take U1 S1 transpose, U1 is user 1, S1 is smartphone 1 transpose, that will result 5.0 because that rating is already given to you. U1 S1 transpose is equal to 5. Similarly, for U2, user 2, if you go for U2 S1 transpose, that is equal to 4.5. Okay, but U3 S1 transpose is not known. U4 S1 transpose is not known. So only it is given that U1 S1 transpose is equal to 5, U2 S1 transpose is 4.5. So if 2 ratings are given to you, you can formulate into 2 different equations. One feature is X1 another feature is x2. For example, let me write here u1 s1 transpose is equal to 5. Now, suppose I'll tell you the user feature, user u1 feature, okay, based upon their interest, battery and display value, it is 0.9 and 0.1. Okay, so what we can do? So I can write u1 is 0.9 and 0.1 from the next table. S1 is already given to you, okay, that you are assuming as x1 and x2 transpose is equal to 5. So if you find it, then it will be 0.9 x1 plus 0.1 x2 is equal to 5. This is one equation. Let's it be equation number 1. Similarly, if you go for u2 s1 transpose is equal to 4.5, and if you see the user 2 feature here, which is 0.8 and 0.20, so I can write 0.8, 0.2 transpose is equal to, sorry, 0.8, 0.2 transpose. S1, S2, we assume that X1, X2 transpose is equal to 4.5. So if I calculate this one in terms of equation, I'll get 0.8 X1 plus 0.2 X2 is equal to 4.5. So that is my equation 2. Okay. So these are the equation you can see. This is your equation number 1. This is your equation number 2. So what's your 2 equation? And you have 2 unknown. X1 is a unknown, X2 is a unknown. So if there are 2 unknowns are there, you need minimum 2 equations to solve that particular problem. Okay. So now if I multiply, okay, so if I multiply it by 2, if I multiply this by 2, so 0.90 becomes 1.8, 0.20 becomes 0.2, and 5 becomes 10, right or no? Then if I subtract these 2 equations, this will be cancelled out, right or no? This will be cancelled out. So 1.8 minus 0.8 if I do, so it is only x1, then it is 10 minus 4.5, so you will get 5.5. What it indicates? It indicates that 5.5 is the value of x1. And once you know the value of x1, if you put in this equation, let it be 0.8 x1 plus 0.2 x2 is equal to 4.5. And if I put the x1 value is 5.5, so 0.8 into 5.5 plus 0.2 x2 is equal to 4.5. And if you solve this one, so for example, 0.8 into 0.2, sorry, 0.8 into 5.5, it is coming 4.4 plus 0.2 x2 is equal to 4.5. So 0.2 x2 is equal to 0.1. Okay. And if I find x2 is equal to 0.1 divided by 0.2, so you will get 0.5. So here you got x1 value is 5.5. Here you got x2 value is 0.5. So now equation 1 and equation 2 will gives, if you solve this one, you got x1 is equal to 5.5, x2 is equal to 0.5. So you are given with user, item, rating matrix, and you are also given with the user feature matrix, Using these two, what you can find? You can find item feature matrix. Okay. So once you determine this x1 and x2, you can go for any different you can calculate similarly x1, x2 for smartphone, s2 also. Item feature of smartphone s1 you got, right? This is with respect to s1. Similarly, we can calculate for s2. So for example, if you calculate for s2 by taking two equation, how to make two equation? So here you can say u1 s2 transpose is equal to 5.0 and u3 s2 transpose is equal to 0.5. So if you solve this one by taking s2 as x1 and x2, what you will get? You will get 5 and 5.5 and 0. 5.5 and 0. Similarly, S3 case you will get 5 and 0. S4 case you will get 0.5 and 5.5. S5 case you will get 2.7 and 5.25. So now if you solve like this, then you will get these values. So now all feature vectors are known. That means I can say item feature matrix is now known to you. So hence the recommendation will be mapping of user feature matrix and item feature matrix. So for example, user U1 whose name is Aman. So you want to recommend some item to user U1 based on his experience. So what we can do? U1 S1 transpose, U1 S2 transpose, U3 U1 S3 transpose, U1 S4 transpose, and U1 S5 transpose you have to calculate. Okay. U1 S1 transpose, U1 S2 transpose, U1 S3 transpose, U1 S4 transpose, and U1 S5 transpose you have to find. So you know U1 value and you have calculated these values which are S1, S2, S3, S4, S5 respectively. So if you calculate these, you will get these values 5, 4.99, 4.95, 1 and 2.9. Out of these values, the maximum value is 5. That's why S1 you are going to recommend to Aman. Out of the other values, S2 is the second best. So I am suggesting S2 second. 4.95 is third. And 2.9 is fourth, that is S5. Then S4 is 1. Okay. Then followed by S4 whose value is 1. So in this order, you are going to suggest items to the user Aman. Okay. For example, user U1 has suggested S1, you have suggested already S1. Then you can go for S2, S3, S5, S4. Or if you go for, let's say, top K recommendation, let's say K is equal to 3. So you are going to suggest S1, S2, S3 in this particular order. So this is an example where you can easily understand how collaborative filtering algorithm works. So you are given with the user item rating matrix and you are given with the user feature matrix. Okay. But item feature matrix you need to find. But when you go for content-based filtering system, okay, so here this system recommend item based upon the similarity comparison between the content of the item and user profile. Like here I am showing you two tables. In one table, you have features about the smartphones. In another table, you have features about the user. So we have taken two features. One is battery and display. And you have a feature vector. Okay, based upon the feature, we create a feature vector. So when these things are already given to you, it is easy to find the recommendation. For example, I can calculate U1 S1 transpose. I can calculate U1 S2 transpose. Okay, I can also calculate U1 S3 transpose. I can calculate U1 S4 transpose. I can also calculate U1 S5 transpose. Okay. So if you calculate this one, okay, and take the maximum one, the item that is going to come first, okay, let's say out of this value is minimum. So I'm going to suggest S2 first. Okay, in this way, I am going to suggest a particular item to the user. So it is very straightforward when you go for content-based system. But when you go for collaborative filtering system, you are converting the user item rating matrix and user feature matrix to item feature matrix. Okay. So let us see how it is doing here. So if you go for Aman case, so Aman is your user U1, U1 S1 transpose, U1 S2 transpose, U1 S3 transpose, U1 S4 transpose, U1 S5 transpose. So I am getting these values. Out of these values, you know, the highest one is 0.9. So I am going to suggest 0.9, that is S2 to I'm going to suggest smartphone 2 to Aman. Okay. If S2 is purchased by Aman, then you can go for S3, which is the next best, which is smartphone 3. Okay, so in this way, actually, the content-based recommendation system works. Okay, is there any question related to these two? Anybody? Content-based system and collaborative filtering system. Okay. So now we'll see one of the important problem that happens in the collaborative filtering system. So that problem is called as a cold start problem. So cold start problem happens with respect to user and with respect to the item. So let us see whether cold start problem happens in the collaborative filtering or content-based system or both. So what is cold start problem? For example, in your, let's say in database, you have 11 users and you have 15 items. You have 11 users and a 15 items. So when I talk about new user, so let's say U12 is the new user. Okay, U12 is the new user. So when a new user is added into the database, which item you are going to suggest to user number 12? So that is called as the cold start problem. Okay, like here you can see U12 is my new user. When U12 is added to the system, which item I am going to assign to user number 12? So that is a question mark. Somebody can say that out of 15 items, let's say the most purchased item is, let's say, I7. So I can suggest I7 to U12. But user may not like that one. Or somebody can say that the item which is rated 5 out of 5. For example, 5 out of 5 and purchased by maximum user. Let's say in that case, suppose I am saying, let's say I1 is coming. So user 12 may not like I1 also. So this particular problem happens in the cold start, which we call as cold start problem in collaborative filtering system. Not only in the new user, when you go for new item, suppose you have 15 items and you are adding 16th item into your e-commerce site. So the 16th item, okay, whether you are going to recommend this item to user 1 or user 2 or user 11. So that is also a question mark. Right. Somebody can say that the user who purchased maximum items, suppose for example, I can say here, U1 purchased maximum item, let's say 6 items. I think 6 is the maximum one. So I'll suggest I16 to U1. So U1 may not like I16 also. Similarly, somebody can say not only we are going to see maximum number of items, we will see the rating values. For example, if you see, I think the rating values. So this is the 6 items and rating value is almost 5 and 1 is 3. So that is user number 5. U5 is recommended with item 16. So that user also may not like the item. So this new item is not recommended to any user. Okay, so that actually happens in the collaborative filtering system, which we refer as cold start problem. So cold start problem can be categorized based upon the new user and new item. Now we'll see whether the same problem happens in the content-based system or not. Okay, so let us see. This is my content-based system. In content-based system, I told you there is a item feature matrix and there is a user feature matrix. If you talk about item feature matrix, we have, let's say, we are maintaining a set of movies as a set of items. So every movie has a type, that is genre, director, plot, running time, and other things. Similarly, for user also, we are maintaining user ID, what type of movie user likes, that is genre, and so on. So user profile is there, item profile is there. So when you add a new user in the content-based system, we can ask the user whether you like terror type movie, romantic type movie, crime type movie, or horror type movie. Or somebody can also go for multiple, or you can say multiple types of movies also. So if the user mentioned, let's say user is interested in crime type movie. So we can go to item feature matrix and search the movies that are of crime type. And out of the crime type movie, those movies or the movie which is rated most, so that we are going to recommend to this particular user. Okay, so in this way, the new user will get a type of movie. At least some movies will be recommended to this particular user. So the recommendation is not nil like collaborative filtering system. Not only that, suppose a new item is added. For example, okay, this is new. Okay, suppose I am adding a new item, a new movie is released. So that movie is also having a genre, a director, plot, running time, and other things. So suppose that movie is crime type. So I will come to the user profile, check the user that are or those users are interested for crime type movie. So I'll find the users and suggest the item. Right? So in this way, we are going to suggest a movie to a user or add something into the item. So this is the way the content-based recommendation system works. Okay, so cold start problem which happens in the collaborative filtering system is avoided in the case of content-based recommendation system. So this addresses our first question, that is, which information is important to make recommendation. Okay, now we'll proceed for the second question. The second question, which I told you with respect to set of items, not with respect to the recommendation system, that is how to evaluate a recommendation system. Suppose a recommendation system is there, so how you are going to evaluate that particular system. So in order to evaluate anything, so you need some performance metrics or some performance measures. That performance measures will help you to say that whether a recommendation system is correctly suggesting the item or not. So the first one here you can see, that is called as accuracy. For any machine learning model, we focus more on accuracy. For example, your recommendation system is suggesting I1 and I3. So whether the user U1, let it be user U1, whether U1 like I1 or I3. 3, I1 or I3 or both I1 and I3. So that comes under the accuracy. So accuracy says that, do I like what the recommendation system recommend me? The recommendation system is suggesting I1 and I3, but whether I like the item I1 or I3. So that comes under the accuracy. For example, user 1 like I1, dislike I3. So your accuracy is 50%. Let's say this user has not liked I1 as well as I3. So you can say accuracy is 0. But if a user likes both I1 and I3, the accuracy is 100%. So that is one of the measure. So second one, we can say that is called as diversity. So diversity addresses a question, that is, does the recommendation system offer me different kind of items? Does the recommendation system offer me different kind of item? So it is not only domain specific. Okay, suppose somebody is interested in books category. The recommendation system should not give all the things related to books only. Rather than recommendation system also need to explore other categories and suggest. So that comes under the diversity. Similarly, we have another measure, that is trust. Trust is also depends on other factors like reliability and explaining recommendation. Okay, if you give a detail about a particular recommendation, if you tell other details or information, that will help us to build the trust. And it is a personal opinion. Trust always points to a personal opinion, whereas reputation points to the public opinion. So here we address the question, has the recommendation system the ability to convince me about their recommendation? For example, if you have added a particular item into your cart, then recommendation system is explaining that these many users have purchased this item in last 1 week or 1 month. Or recommendation system also suggests that if you purchase this item by today midnight, then it is going to be delivered day after tomorrow. So these are the different ways we are convincing the user to purchase the item. Or you can launch a small offer of, let's say, discount of 100 rupees or 2%, 3%, something like that, which help us which help the user to purchase the item. Some additional information we are providing and convincing the user. Another one is called as serendipity. Serendipity is how surprising are the recommendations. For example, nowadays, whenever you registered a particular system, then they are registering your date of birth, your anniversary, or other dates, other important dates. So they mentioned that if you purchase in your this particular month, let's say your birthday month or anniversary month, then you get some additional discount. Right? So sometimes these recommendations are quite surprising. Right? Some internal things, internal informations they are extracting, and they are launching different type of offers to convince the user to purchase a particular item. So these are some of the evaluation measures that you can take to, I can say, to evaluate the performance of a recommendation system. Some other parameters are that I'll tell you once we complete how to implement the recommendation system. So here you can see, although I told you the broad view of a recommendation system, where you have database, you have a recommendation engine, and you have set of items, and you have a user. Right, here also you can see there is a database, there is a user, it is suggesting a particular item, and we will go in detail about the recommendation system. So I told you as a definition that recommendation system is a subclass of information filtering system. So database contain whole information, right? Whole information about a particular user and items. And we don't need all information. So what we will do? We will extract some of the information from this database. For example, I extracted this particular movie from the database using this filter. Okay, so I used a particular filter. The filter is extracting a set of movies. One of the movies is this one. Then a user has certain feature, like I told you in the case of smartphone, battery and display are the two features. And let's say this particular movie is also having two features, like battery and display. So I'm comparing the feature of the user with feature of the item. So when you measure the feature of a particular user and item, you will get a score. For example, here you are getting the score is 4.5. Okay. So the process what you follow is called as matching. Matching helps you to generate a particular score. Not only that, I can take another movie. Okay. I'll again extracted this movie from the database and checked with the user feature. Let's say I'm getting the score is 2.3. Earlier I got the score is 4.5 for a particular movie. Now I'm getting a score for score that is 2.3. Then I got another movie, right? Another movie. Then again I matched with the user. Then I got the score is 4.7. Like that, you have to take a set of movies, let's say 10 movies or 20 movies, and generate the match score between the user and the item. Once you generate the match score between the user and item, select the movies that are having high score. For example, if I ask you to choose top two movies out of all the score, then definitely you are going to choose this particular movie, which is 4.7, and this movie, which is 4.5. So initially, I am extracting a subset of movies, checking that movies with the interest of a particular user to generate the matching score. Once matching score is generated, you need another filter. You need another filter to shortlist some of the movies out of the subset of the movies. Okay. So if you see that this particular architecture of a recommendation system, you have two filters. This is one filter. This is another filter. Okay. And you have set of movies which you have extracted from the database. That's why you need a filter. And you need a matching unit to compare, to look into the features of the user and item, and you need another filter. So you need two filter and one matching unit to perform the whole task. And again, this filter, when we talk about, it provides additional constraints. You can go for cross domain, you can go for geographical domain, you can go for a specific domain, you can go for a general domain, and so on. However, this filter is not used for that particular purpose. This filter is used to select the highest score, highest score movies out of a subset of movies. So now, if you compare this diagram with what diagram I told you earlier, where you can see there is a user, there is a database, there is a recommendation system, and there are a set of items. So now, if you go for the internal architecture of a recommendation system, in that architecture, you have two different filter and one matching unit. Okay, so in this way, the recommendation system internal architecture can be defined. You have to write two filter, one for two filter and one matching unit, so that the complete recommendation system can be visualized. Now go back to our previous discussion, which I told you types of recommendation system. So if you go for types of recommendation system, I told you it is of two types. One is collaborative filtering system, another is content-based recommendation system. But collaborative filtering and content-based recommendation system is again divided into memory-based and model-based. So let us see what is the difference between the memory-based system and model-based system. So memory-based systems act only on the metrics of user ratings per item. We have a user item matrix. So memory-based system uses that particular matrix and it uses any rating generated before for the referral process. For example, if you have purchased 10 items, for the 10 items you have suggested some ratings. That ratings are also need to be considered in the referral process. And memory-based system also uses similarity matrices. Like if you want to compare two different user, or you want to compare two different item, or you want to take ratio of the user and item. So on such cases, the memory-based method uses the similarity matrices. Right. Just I want to know that which two users are similar, or which two items are similar, or the ratio between these a particular set of two users with respect to two items. So their memory-based methods can work. But model-based system is also taking, if you when you go for collaborative filtering system, it is also taking the rating matrix, but it creates a model that generates the recommendation. Like we have seen in the case of regression. Regression, we create a different type of model. And once you create the model is not looking into the previous data, right? Rather than the model consider the model is trained with the past data and based upon that it is suggesting something. So the model is generating the recommendation. And we consider a method is model based if new information from any user outdate the model. Okay. So suppose your model is trained with some data. So that model is not going to sustain for longer period of time. So in a periodically, you have to add some additional information. Otherwise, the model is going to be outdated that data. Otherwise, if you are not updating the model periodically, some new information will come which is not there in your model. So your model is going to be fail in that particular case. Okay. Now let us see one by one. If you go for memory-based collaborative filtering system, so you are given with this particular matrix, which we call as user item rating matrix. Here, for example, if you look into this particular matrix, you can see the interest of user U1, U2, U3, and U10. They are more or less same. The interest of U4, U5, U6, and U11 more or less same. And the interest of U7, U8, U9 is also more or less same. For example, here, the system predicts that, like if you talk about user U3, the interest of user U3 is matching with the user U1 and U2. Interest of U3 is matching with user U1 and U2. Okay. So what it will do? User 3 has not purchased item number 3 or item number 7. As user 3 is related to U1, U2 and their interest is related. So these two items can be suggested to U3. But out of these two items, if you see, the item number I3 is preferable because user U2 has rated 5 out of 5. But for I7, both have rated low, that is 2 and 1. So the system predicts that user 3 will like I3 based upon U1, U2 rating on I3. So that is called as a memory-based system for collaborative filtering. But when you go for model-based, the database is not directly applied. Database means the database that contain user item rating matrix is not directly applied. Rather than the database is converted into a model database. So how to convert a database into model database? Database is converted to model database based upon the learner. So database is having your user item rating matrix. But if you want to convert it into model database, then model database you have users feature and items feature. For example, here you can see user has feature 1, feature 2 up to feature k. Item is having a feature 1, feature 2 up to feature k. Okay. So one of the popular method called as factorization, which help us to convert the database into model database. And once you have model database or features, you are not dependent on user item rating matrix. So you are suggesting the item based upon the feature of the user and feature of the item. So, but if you go for like for example, in this example, if you see user has 3 features, I can say user has 3 features 0.95, 0.02 and 0.02 for feature 1, feature 2 and feature 3. And item has 3 features 0.87, 0.50 and 0.50. Okay. So now if I calculate the score based upon this feature, so I'll multiply the corresponding feature of a user with the corresponding feature of an item. For example, 0.95 is multiplied with 0.95 is multiplied by 0.87, 0.02 is multiplied by 0.50, and 0.02 is multiplied by 0.50. So this results, the score value is 0.86. So if you see for item number 3 and user number 3, which I told you, based on the recommendation of user 1, user 2, because they rated 5 out of 5. So the score that is generated here is 0.86. So this is an example of a model-based system. And if you want to see the model-based systems architecture, so earlier I told you database, recommendation system, user and set of items. So here you are applying the filtering approach. If you remember, this filtering process is applied to the database. But now it is not applied to the database. It is applied to the model database. Okay. So in this way, this model-based recommendation system works. Now, if you come to memory-based system or content-based filtering system, content-based system. This first one is collaborative filtering. Second one is content-based. So in that case, if you see, for example, you are reading a particular newspaper, which I referred here as a item 2. In this newspaper, you find some notable words or keywords. For example, in this news, World Bank can be a keyword. Gross domestic product, which we call as GDP, is one of the popular word, or it is more or less related to economy. So I made a particular table in which I have written these are the keywords or terms and that are repeated these many times in this particular document. So based upon their repetition, I can find matrix. So earlier I am making a user item rating matrix, but user item rating matrix is not there. User item rating matrix is not available. User item rating matrix is not available for what? Content-based system. So here I am making a matrix that is called as item term matrix. Item in rows, term in the column. Okay. Item term matrix. Earlier it is user item matrix. So here you can see these are the items and these are the tops. Like if you talk about news article I1, where goal, RM, FCV, CR7, all is repeated. Similarly, if you talk about I2, these are some of the words that are repeated. There is goal, RM, FCB, and ball. Similarly, I3 case, goal, RM, FCB, CR7, and ball is repeated. Right. So now, if you see here, by looking into this, what you can say, I1, I2, I3 is more or less having the same item. So if somebody is interested in an article where I1, like I1 article, then I2 and I3 can also be, I2 and I3 can also be considered by that particular user or suggested to that particular user. So that way, the memory-based system actually works. For example, here you can see the system predicts that user U will like item I3 because I1 and I2 is seen by that particular I1 and I2 is seen by a particular user. So I3 is equivalent to I1 and I2. So we can recommend that particular item to the user. But when you go for model-based, content-based system, so in that case, the database is converted to the model database like as usual for getting some features. Okay, so once you get the features, using that features, you can calculate a particular score. Okay, you can get a score value. For example, here you can see in my database, in addition to user feature and item feature, I have a term feature as well. I have user feature, I have item feature, and I have term features. Like here you can see item ID, term, and number of times. Okay. Then based upon this, I am going to extract the feature. So you can see term is nothing but item term matrix, which I told you. Okay, how many times a particular keyword is repeated in the items. Then I am getting the feature like term features, then item feature and user feature. Let's say having k features. What I can do? So in order to get a score, I have to take the term feature, item feature, and user features. So if I do together, then I'll get a score value. Like here you can see, I'm getting a score value. Here I'm showing you with respect to user and item. But any additional term I have to use, that is term feature, and I have to multiply that to get the score value. So in this way, you are going to generate a particular score value in the model-based system. Now, in order to evaluate the accuracy of a recommendation system, the database is split into two parts. One is the training data set and it is testing data set. You know, in machine learning model, a database is divided into, let's say, 80-20 ratio or let's say 75-25 ratio. Right? Training testing. Then we'll go for a confusion matrix. In confusion matrix, in the left part, means in row wise, I am taking the recommendation. Column part, I am taking whether a user like a particular item or dislike a particular item. For example, in this case, like these are the two movies that are suggested by the recommendation system. Okay, whether the user like these two items or not, that is more important. That we will see in the process of testing. Suppose in the process of testing, we found that user like these two items. So there is a similarity between these two items. But when I compare these two items, there is no similarity. Right or not? For example, if you talk about this particular item. Okay. So whether user like this item, no. You can see in the test case, this item is not there. But whether recommendation system suggested that item, yes. So that is considered as false positive case, or we call it as a type 1 error. So if recommendation system has suggested an item, but user dislike that item, that is called as false positive case. But if recommendation system has not suggested this item, like the movie Avatar, is not suggested by the recommendation system, but user like that particular item, then that is called as your false negative case. Similarly, we can say if a recommendation system suggests an item and user like that item, so that is a true positive case. And if a recommendation system is not suggested and user is also not interested in that item, means recommendation system case also it is no, and user case also it is no, then we call that as true negative case. Okay, so in this way you can make a confusion matrix where you can specify false positive case, false negative case, true positive case, and true negative case. Apart from these, we also consider some of the matrices Like here you can see, we can see precision. Okay, we can see recall, and we can see F score. So precision is calculated. In order to calculate the precision, it is nothing but true positive cases, number of true positive cases divided by number of true positive cases plus false positive cases. But in order to calculate recall, recall is nothing but number of true positive cases divided by true positive cases plus false negative cases. Okay, so this will help you to calculate the precision, and this will help you to calculate the recall. But there is a trade-off between the precision and recall. So in order to balance these two, so we have another measure that is called as F score. So F score is calculated. Okay, F score is calculated based on the precision and recall, and the formula for it is that 2 into precision plus 2 into precision into recall divided by precision plus recall. So in this way, we are going to calculate the precision recall and F1 score. If F1 score of a particular model is better, then definitely we are going to select that model as the best model. Yeah, this is the true negative cases which I told you. If a movie is not suggested by the recommendation system and user also dislike that item, we call that as a true negative cases. Apart from this, we have another two metrics. One is called, one matrix is calculated as MAE, another is called as RMSE. So one is called mean absolute error. Mean absolute error, we calculate the difference between the predicted rating and actual rating. So we took modular. For example, recommendation system has suggested that we are going to rate 4.5. The predicted rating is 4.5. That is expected from a user, but user actually rated 4. So the difference between 4.4, 4.5 and 4 is 0.5. So we put a modulus. That is called as mean absolute error. But another is RMSE error. So instead of taking that, suppose if you are taking predicted rating minus actual rating and its whole square. Okay, for example, predicted rating is here 4.5, actual rating is 4. So I can take 4.5 minus 4 whole square and root over. As I'm taking one rating, it is divided by 1. So that will give me RMSE value. So our objective is to reduce the value of MAE. Okay, means that error value should be minimized. MAE should be minimum, RMSE should be minimum, and precision, recall, and F1 score should be maximum. So on that basis, we can decide whether we go for if you are comparing multiple model. So that those the model which is giving you the better precision and recall at MAE RMSE value, okay, improved value, that is going to be considered as the best recommendation system model. Okay, so this is all for this particular lecture. So we'll stop here, and in tomorrow's lecture, we'll conduct the activities and we'll see the similarity function. So if you have any question, you can ask.